Hello everyone and welcome back to the channel. We have discussed the two-phase commit or 2PC protocol for distributed transactions, noting its strong consistency guarantees but also its major flaw, the blocking problem. What if we design a distributed commit protocol that avoids blocking? This is where 3 commit phase or 3PC protocol enters the picture. While less common in practice, understanding 3PC in system design interviews demonstrates a deep insight into the complexities and trade-offs of distributed systems. Today, we are diving into what 3PC is and how it attempts to solve 2PC's infamous blocking issue. Okay, so let's first try to understand the problem. Okay. So, as a quick recap, 2PC is a protocol for achieving atomic commitment across multiple distributed resources. It guarantees that all participants either commit or roll back a transaction. However, 2PC suffer from critical weakness. Basically, if this coordinator fails during phase 2, which is the commit or rollback phase, participants that have entered the prepared state might be left hanging indefinitely, holding locks on resources. They don't know whether to commit or roll back, leading to resource starvation and reduced availability. This is a blocking problem. Participants are blocked until the coordinator recovers or manual intervention occurs. 3PC was convinced as way to overcome this very limitation. Okay, so what is exactly 3-phase commit? The 3-phase commit or 3PC is an extension of 2PC designed to eliminate this blocking behavior. It aims to achieve atomic commitment while being non-blocking in the face of coordinator failure, provided that network partitions do not occur. Network partitions which prevent participants from talking to any other node. It adds an extra phase to allow participants to make a local decision even if the coordinator fails, thereby releasing locks sooner. Okay, let's try to understand how it works. And I hope this is quite easy for you to look at. Okay, so we have 3 phases. First, we have the vote request phase. The coordinator here, or the sender, will send a can commit. Like similar to 2PC, the coordinator will ask all participants if they can commit the transaction. Number 2, the participants will respond. Like each participant will perform local checks and logs changes, then responds yes or no. If any participant responds no or timeout, the coordinator will abort the transaction and sends a abort message to all. Next, we have phase number 2. Phase number 2, basically this is the pre-commit phase. The coordinator will pre-commit. The coordinator only if all participants responded yes in phase 1, the coordinator sends a pre-commit message to all participants. This signals that all parties are ready and have agreed to commit. Number 2, on the second phase, the participants will respond or act according to that. So basically, each participant receives a pre-commit, permanently logs the decision, meaning it's ready to commit but hasn't yet, and then will send an act acknowledgement back to the coordinator. The key difference here from 2PC, at this point, participants know that all other participants are also ready. They still hold locks but are in a state where they can literally commit if they don't hear back from the coordinator under a specific condition. This is crucial for non-blocking. Okay? So again, in the second commit, or here in the dissemination phase, each participant will receive a pre-commit, permanently logs the decision. And then the thing is different from 2PC is that all participants know that all other participants are also ready. Lastly, we have decision making or commit. Here the coordinator will send a do commit only after receives act from all participants in phase 2. The coordinator will send do commit message to all participants. Participants will commit and release, like each participant commits its local transaction and release all locks. The then response done to the coordinator. Okay, let's try to understand the advantages of this type of pattern. So while 3PC attempts to solve 2PC blocking problem, it introduces its own set of trade-offs. The pros, which is quite obvious, the non-blocking in some failure scenarios is gone. It can avoid blocking if the coordinator fails in certain states, particularly if a participant can infer the global decision based on messages from other participants. Like if receives a pre-commit but no do commit, it can eventually commit if no apport is received and other participants are also ready. Okay? The cons, we have 4 things we want to talk about. The first thing, which I guess it's quite obvious, it's increased complexity. Like adds another phase and more message, making the protocol significantly more complex to implement and manage than 2PC. Number 2, we have higher latency because we have more network round trips, which will inherently increase the latency of transactions. Number 3, we have assumption about network, like it relies on the assumption that network partitions do not occur. Network partitions where nodes are completely isolated, okay? If a network partition occurs, 3PC can still lead to inconsistencies, okay? Basically, it doesn't solve partitions. Lastly, we have rare in practice. Due to its added complexity, increased latency, and the fact that it doesn't solve inconsistencies under network partitions, 3PC is rarely used in real-world distributed systems compared to 2PC or the Saga pattern. Okay, how to talk about 3PC in system design interviews. In system design interviews, 3PC is typically mentioned as a follow-up to 2PC decision. It demonstrates your awareness of 2PC blocking's flow and potential solutions. You would bring it up when asked about achieving atomicity in distributed transactions, and especially when exploring ways to avoid blocking. However, it's crucial to state its practical limitations. It's more complex, adds latency, and doesn't fully solve the problem in face of network partitions. For more modern microservices, the Saga pattern is usually preferred for its non-blocking asynchronous nature. Despite leading to eventual consistency, understanding 3PC highlights your comprehensive grasp of distributed system challenges, even if it's not a common practical solution. So that's it for this video, and see you in the future.